Hello and welcome to your next lesson, which is covering adding and subtracting fractions with like denominators. Now I'm going to go ahead and go over some of the steps here, but some things to keep in mind which are really important, which is number one, when you add and subtract fractions, you only add the numerators. Don't add anything else. One of the first things you have to keep in mind when you are adding or subtracting fractions is that really you're paying close attention to the numerators. We're not really going to do anything with the denominators. So only add these things, 5 and 1. The numerator is the top number, the denominator is the bottom number. And one thing that's really, really important that you keep in mind when you're adding or subtracting fractions is to never add or subtract the denominators, ever. Don't add them. 8 and 8, yes, that makes 16, but we're not adding them. We're adding 5/8 plus 1/8. Okay, so here's your steps. Pretty simple. These steps are all going to be pretty much the same. Add the numerators or subtract. Simplify, that's if needed. You're not always going to need to simplify. And then you're finished. Make sure you check your answer. Make sure it's not improper. If it's improper, change it to a mixed number. If it can be reduced, reduce it. Okay, so I'm going to go ahead and show you. And I'm going to show you using fraction strips, which you guys should all have as well. And I'm going to expect you, the student, to be able to model this as well. So right here we have 5/8, and my model here represents 5/8. And I'm going to add 1/8. I'm going to add 1/8 to it. There we go. So there's 5/8, there's 1/8. When I add 1/8 to it like that, what do we have? I know this seems really simple, but it just needs to be said. How many 8s do we have? So I'm going to go ahead and add these up. 1, 2, 3, 4, 5, 6. So what do we have? We have 6/8. So we added the numerators. Now let's see, is there anything that we need to simplify? And if we look at modeling, if we look at our fraction strips, try to match up your fraction strips with these 6/8 and see if you can match anything up. And you might notice that 1/4 matches up. So let's go ahead and look at our fraction strips and try to match up one of your fraction strips with these 6/8 and see if you can match up thirds with it. Can you match up fifths with it? Is there a way to match up half with it perhaps? And you need it to match up exactly. You know, you need these ends to meet at the folds or at the creases here. If you start poking around with your fraction strips, you'll notice that you can put 1/4, 1/4, 1/4 on top of it or next to it, and it will match up perfectly. 6/8 is exactly the same thing as 3/4. So when we're dealing with fractions, we want to put things in lowest terms. You want to make sure that 3/4 is exactly the same as 6/8. Now I know what you're thinking. I know you wanted to say, well, Mr. Oliver, why can I not just say, okay, 6/8, I can divide that by 2 and just reduce it the old-fashioned way, which is perfectly fine. But what we, Mr. Gasson and myself, what we're going to expect of you as math teachers is that you're going to need to model it. And I want you to show us why 6/8 equals 3/4. You need to be able to show that. So we're spending a little bit of time on this first one because, and I know it's an easy problem, but it needs to be said and shown how to model this kind of problem. Okay, moving on to the next one here. We have 3/4 plus 1/4. Okay, now my model right here represents 3/4, 3/4, and I'm going to add 1/4 on top of it. So what do you get when you do that? You get 4/4. So we have 3/4 plus 1/4. What do we get? 1/2. So 1/2 matches up perfectly with 4/4. So anytime you get a fraction where the numerator and the denominator are both the same, 3/3, 4/4, 5/5, etc., that will always equal 1. All you have to do is look at your fraction strips and take any number of fraction strips, take your 5ths, take your 6s, your 8s, whatever, and line them up. You know, put 8/8 together, it should equal exactly the same length as 1/2. Put 5ths together, 5/5, it should equal exactly the same length as 1/2. So there's your modeling. Like I said again, make sure you're able to model this. Adding them, yes, that's simple. 3 plus 1 is 4. So yes, adding them is simple. 3/4 plus 1/4 is 4/4, which equals 1. No doubt about that. Be prepared to be able to model them. Modeling is important. Modeling shows that you understand really what's happening here. And did I mention never add the denominators? I don't know if I did, but I did. But I'm going to mention that again. Never, never, ever add these things. You can multiply them and divide them when we get into that later. That'll be before Christmas. Never, 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 never add or subtract denominators. Those are left alone. Okay, here's another one. Okay, now we're adding 2/3 plus 2/3. So I have 2/3. I have 2/3 right here. 1/3 plus 1/3 is 2/3. And I'm going to add another 2/3. What do we have? Now this is where modeling might get a little tricky. We have 4/3. 4/3. Now what is 4/3 really? Let's clean that up a little bit and use our fraction strips. And what did I just tell you about having the same number of a given denominator? So if we have 4/4 or 5/5, in this case we have 3/3. What does 3/3 equal? That equals 1. There's your 1. There's your whole. So what we're going to do is we're going to regroup it, reorganize it, and clean it up. Put it into lowest terms. There you have it. 1 whole matches up exactly with 3/3. 1 whole on top of 3/3 makes what? Well, right here we have 1. We have 1, and right here we have 1/3. So what's the answer? 1 and 1/3. There's your solution. Here's another example. We have 3/10. Here's my model of 3/10, and we're going to add 5/10 to it. There's 5/10. So there was 3/10. There's 5/10. Now what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8/10. And can that be put into simplest form? Of course it can. So how do we put 8/10 into simplest form? Go ahead and look at your fraction strips and start matching things up. Get out your fourths, get out your thirds, get out your fifths. See what matches up. You want to, again, you remember, you want them to match up end to end. And when you get your fraction strips out, if you look at it, you'll notice that your 8/10, you might want to fold your 8/10. I know, you might have a couple more tenths on here. Fold that part down so that you only have 8/10 showing, and match it up with fifths. And you'll notice that your fifths and your tenths match up perfectly. And how many fifths do we have? We have 4/5. So there you have it. I know what you're thinking again. I can read your mind that you're just thinking, why can't I just divide? And of course you can. 8 divided by 2 is 4. 10 divided by 2 is 5. That's how you reduce fractions. That's great. I'm happy that you can do that. However, know how to model these. That's very important that you know how to model these showing your fraction strips. We want to be able to use those. We're not just cutting them out just to give you busy work. You're cutting them out so that you can model them and understand how fractions work. Today we're just dealing with adding fractions with like denominators. This is the easy stuff. Know how to use your fraction strips with the easiest thing, which is like denominators. Okay, that concludes this lesson. Make sure you guys take good notes. Remember, anybody can sit through a video, press play, and watch it and say they did it. It's another thing to actually watch the video and learn from it. Sitting there watching, that's easy. Learning, that's hard. But make sure you put some effort into really watching these videos, understanding the content, and taking good notes. If you don't understand something, make sure you write down questions and bring them to class the next day. Very important, like I said, it's very important that you sit down, watch these videos, watch these lessons, and really understand them. If you're just sitting at your desk, pressing play, and jotting down a few notes, that's not good enough. You need to really think about what's going on and learn how these are done. That does it. Everyone have a great night. See you tomorrow.